Hi guys, welcome back to the CS Classroom. Today we're going to cover topic 1 called Systems and Organizations, and this is topic 1 in the IB Computer Science curriculum. I don't hesitate to say that this is one of the easier topics in the curriculum. One of the problems though is there's lots of random bits of information that you need to know and memorize. So it made it very difficult to actually organize the slideshow. However, I've included all of those random bits in as coherent a way as possible. Enjoy. So in general, this topic is about how to design software for organizations and what the implications are for changing software that an organization uses. So changing from an old piece of software to a new piece of software. We'll also talk about testing software, backing up data, releasing software, and maintaining software. And we're not going to talk about this from a technical perspective. Well, there's going to be some technicality, but you're not actually going to have to write any code or do anything quantitative. Now, there are a few considerations for changing to a new system. One of them is the extent of the change. Are you completely changing a software system so that the user interface is different and it has drastically different features, or are you simply just upgrading the color of the web pages? The next consideration is the limitations of the new system, particularly as compared to an older software system. What can't you do anymore? And finally, we want to take into consideration the context in which the system will be used. Any organizational issues, more specifically, any issues that the software will create within the company it's being implemented in, and any change in the roles of users, what users can and must do with this software. A great example of this is maybe you are at a school and your school uses a certain piece of software to record grades, attendance, and discipline. But then all of a sudden, a new principal comes in and wants to completely change to a new piece of software. In this topic, we're going to talk about what the implications might be for the teachers in that school and for the workforce in general. Now, there are some difficulties in changing software systems. First of all, users don't like change. In general, people don't like to learn new things. So whenever you change a software system, it's going to piss people off. Also, some features might be omitted or left out. So for whatever reason, maybe to make space for a new feature, maybe because there just wasn't enough time to recreate an old feature, certain features that may have been useful before might be left out. Additionally, the old system may be faster. So a new system may have more features, but that might come at a cost in terms of performance. Alternatively, you might have a different company or developers building a new system who just program in a different way or are less competent than those who created the old system. Additionally, you might have incompatibility with other systems. Now, for example, that piece of software we were talking about in a school, the old piece of software that was used in a school to keep track of grades, homework, attendance, may have been compatible with Google Classroom, which allowed teachers to use that in tandem with their software. However, the new piece of software the school is upgraded to may not be compatible with Google Classroom anymore. And this may present a problem for a lot of teachers who are used to using both of those in conjunction. Finally, there might be data loss. Whenever you move to a new piece of software, you need to migrate or move the data from the old piece of software to the new piece of software. In the process of migrating, which could actually be migrating 100 terabytes or 1,000 terabytes of data, depending on how much is stored, some data could be lost for a variety of reasons that we'll go over later on. And most importantly, the switching to new software might be expensive. This might not be off-the-shelf software. It might have to be created in a custom manner for the organization in which it's used. Just even buying off-the-shelf software might be really expensive. For example, a lot of your teachers probably use a piece of software called ManageBack, and that's probably one of the only pieces of software that's specifically designed for IB schools. And you know what? It's really expensive. Now, when you're switching from one piece of software to another, there are 4 general ways to make that switch, and you need to know all of these, as well as the advantages and disadvantages. The first is the direct changeover. So this means that you just stop running your old system and then just start your new system immediately. So you may just stop running, or you may just stop allowing teachers to use the old piece of software and then immediately have them install and use the new piece of software. The second way is parallel. So you have the old and new system running concurrently or at the same time, with new data being entered into both systems. So you might have both so in your school, for example, you might have both your old software system for keeping track of grades, attendance, etc., and a new piece of software running at the same time, with teachers entering data into both, which can be understandably tedious. Third, a pilot system. This is when a new system is tested with a small part of an organization, refined, and then expanded to the entirety of the organization. So for example, in your school, you might have 4 or 5 teachers using the new software to work out all the kinks. And then once they've understood how to use the software, and once any bugs have been fixed in that software, all the teachers will then adopt it. And finally, we have the phase transition. So this means that features of software are introduced in phases, features of the new software are introduced in phases, while the old system is gradually phased out, feature by feature. So for example, going back to our school example, the functionality for taking attendance might be phased out in the old software, and teachers might have to use a new software for that. And then 3 months later, maybe the gradebook functionality is phased out in the old piece of software, and the new piece of software, teachers now need to put all of their grades. Now, it's important to know some pros and cons. For direct changeover, you're making a pretty abrupt change, which can be problematic for some users, and doesn't really give much time to work out any kinks in using the software or any bugs in that software itself. However, the new system is available immediately, and there's not really much waiting around to use the new system. Another problem with that is that there's no backup in case of failure, right? So if you directly move to the new system, the new software system, and you've basically turned off or you've mothballed the old software system, then you don't really have a backup in case of failure. You can't just go back to the other one quickly and easily. So really, direct changeover is a bit of a Hail Mary. You are just adopting the new software immediately. You're just getting rid of the old software, and you don't really have any redundancy or any protections in place in case things go wrong. With parallel running, you do have some backup, right? So if the new system fails, since you're using both systems, you can just continue to use the old system and stop using the new one. Also, output from both systems can be compared to verify that the new system works correctly. Or, more specifically, you could have teachers use both systems and then tell the administration which one they like best, right? So this could be true from not only the perspective of just pure how does the program work, but also from the perspective, does this work for us? Now, there's some cons. The main con, as with many other ways of switching software, is that while there is a low risk, this is quite expensive because you need to have both software systems running, which I guess this doesn't make sense in our school example, but if you think of like large-scale servers or just gigantic platforms, let's say even cloud applications running at the same time, that requires money in terms of computers that have processing power and memory to keep those going. When you're operating more than one software system, you're using resources, and that costs money. So having 2 systems running at the same time is always going to cost more than just one system. And that is the main sort of downfall, not necessarily downfall, but the main disadvantage of parallel running. Now we have pilot. So this means that all the features are tested before adoption by the whole organization in a small part of the company. This means that if the new system fails, only a small part of the company suffers. You're not really like handicapping the entire company. But also, those staff who use the software can train the others because they've already used that same piece of software in a real-world environment. So in some ways, it's actually not a bad way to go. However, for that specific pilot group, there's no backup in the case of failure because it's basically like a direct changeover, except only for a small piece of the company. So they're taking on that risk. But as we said before, if there is failure, the entire company doesn't suffer, just that small pilot group. And finally, getting to phased conversion. One of the great things about phased conversion is that this is sort of a way of just sticking your feet into the swimming pool without jumping in. You are throwing certain parts of the software at your users, but not all of them at the same time, which allows people to get used to the new system. This also means that training doesn't need to be done in one big block, but it can be done in stages as new features are added. This is just easier for users to adapt to and consume. However, again, for each of these new features that are onloaded or that are being implemented in a new organization, there's no backup for that part of the system. Or the difference is that instead of direct changeover, where you basically have no system if there's a failure, here you still have the rest of the features of your old system that haven't been switched over. So you're only really going to have a problem using one piece or one feature of your new system. Like that's really going to be the only pain point. Now, one of the big challenges moving from one software system to another is data migration. So if you stop using one piece of software and you start using another piece of software for the same purpose, you need to move the data from that piece of software to the new piece of software. And depending on the size of systems, this can be a huge process. It can range from hundreds of gigabytes to thousands or even millions of exabytes, depending on the scale of the transition. But it is necessary. And we're going to go over 5 possible problems that you might encounter while doing a data migration. Now, the first is incompatible file formats. This is actually quite simple. Maybe you have much of your data in your existing piece of software stored in Excel files, but your new piece of software uses CSV files or it uses OpenOffice spreadsheets, which have a different file format. Now, if you try to move Excel data over from one software system to another, then your new software system simply won't be able to read it. So you'd have to convert it before you migrate it over to the new software system. Now, this is a key problem that's often faced in data migration, and it'll take time to solve this. Another, which is kind of similar, is that there are simply differences in the structure of data between two software systems. Now, this means that, for example, all the data in one software system is stored in arrays in memory. In another software system, it's stored in linked lists or trees or graphs. So while the data can be migrated over, you would have to write an algorithm to take data from one data structure and then transfer it to another data structure that could be easily read or processed by your new software system. And beyond just kind of data structures on a low-level programming level, also data stored in tables in one system might be stored in spreadsheets in the other system, or the hierarchy in which data is organized might be different from one system to another. So while in the previous example we were talking about just file formats not being incompatible, in this slide we're talking about the way that data is organized being different from one software system to another. Now, validation rules. Particularly if you've done topic 4, you're familiar with the concept of validation, which are rules that we put in place to make sure that data that is entered by a user is valid, it fits certain parameters. For example, is not negative, or is not greater than 100, or is only integers. Now, the problem is different software systems may have different validation rules. So a piece of data that's valid in one software system may not be valid in the other software system. And this can be problematic because as soon as you put that data in the new software system, it might just reject it and not be able to display or process it. Finally, we've got incomplete data transfer and data conventions. Now, incomplete data transfer is a pretty simple process when you're doing this migration. Due to a variety of reasons that we'll actually go over in a bit here, data may be lost. And that's just an obvious problem because if you lose data, I mean, that sucks, right? And finally, different conventions. So this kind of goes back to validation in a sense. But for example, maybe you are migrating from an American a software system built by Americans for American customers to a software system built in the UK or in Europe that is built for users from those countries. Now, one of the problems is that dates are in a different order in the United States than they are in the UK. Not that this is a huge problem, but when you're moving data from one piece of software to another, that's something that would need to be taken into account with those dates changed to the appropriate format. Another convention that might need to be changed is currencies, dollars to euros, dollars to rubles, to yuan, renminbi, or whatever the target currency might be. And finally, again, software that is typically used by American customers, or an organization might use software that is typically used by American customers or English-speaking customers, but wants to move to a piece of software that that utilizes the language in the country in which they're located. So, for example, a Chinese company might want to adopt software that displays data and can be used all in Mandarin. So making that transition from everything being in English, all your data being in English, to all of a sudden a situation in which your data should be in Mandarin is something that needs to be taken account. Again, none of these are insurmountable, and companies deal with these every day, but they are things that need to be taken account when you're migrating data. Now, a typical situation in which you might want to transition from one software system to another is the case of a legacy system. So particularly like government organizations are quite guilty of operating legacy systems because they don't want to, or they have bureaucrats working in the organization that haven't seen the need to transition to a more modern, probably secure and more efficient software system. Legacy systems in general are old technology, computer systems, or applications that are no longer supported by their parent company or available for purchase. A great example would be on a more consumer level would be the N64. Like you can buy Nintendo 64 on eBay or online somewhere, but I'm pretty sure that Nintendo doesn't actually make Nintendo 64s anymore, or update or support them in any way. Other examples include floppy disks and Windows XP, and this particularly interesting example. So this is titled "Unemployment Checks Are Being Held Up by a Coding Language Almost No One Knows." So this is specific to the United States. Particularly during the COVID-19 epidemic, more people than usual were requesting unemployment benefits. And it wasn't just more people than usual, it was an order of magnitude more people. Now, the program I believe this is actually North Carolina, but in general, the program that was used to process and dispense unemployment benefits was written in a language called COBOL that was commonly used in accounting software, I believe in the early to mid-90s. Now, when the COVID-19 pandemic hit and the usage of these systems went up, in order to match or in order to account for the scale at which they're being used, which was unprecedented, these government agencies that were utilizing such software needed to go and basically find older guys who knew COBOL really well to kind of upgrade these legacy systems, because even the vendors who produced these were no longer supporting them anymore. Now, local versus remote software this is a concept that you're probably pretty well aware of, but just didn't explicitly know the terminology for. Now, local software is that which runs on your computer and is not really tethered to the internet. Like Notepad, Adobe Photoshop, before it was part of the cloud. I guess Notepad's a good example. What are some other examples? Probably most games are actually connected to the internet in some way. But even if these programs are connected to the internet, they still consume resources and run from your computer, directly from your computer, right? So probably out of these, Notepad is the cleanest example, but anything that just runs in your computer, as opposed to remote software, which runs in your web browser or through your web browser. Now, some examples of remote software, which are also synonymous with software as a service or SaaS platforms, are Office 365, Google Docs, Gmail, anything where you can access the entire application, including the data, through your web browser. A local application you access just by clicking on a link on your computer, and the data is going to be stored on your computer as well. Now, it's important to know some points of comparison. So typically, traditional software has a one-time fee, you just pay once and you install it on your computer, versus SaaS is either free, it's like a freemium model, or you pay subscription. Traditional software depends on your underlying operating system and can usually only be used on one computer, versus SaaS, you can use it on any computer as long as it has access to the internet and a web browser. These are not as relevant. Local software, you typically have to install on your computer, versus SaaS software, there's no installation required because you're just running it on your web browser. And updates. So updates you oftentimes need to download, or they're automatically downloaded for you, versus in SaaS software like Google Docs, you generally won't even see the updates, or you won't see the updates happening. All of a sudden, one day you might just log in and the UI looks slightly different, or some feature works slightly differently. Now, there are some benefits and drawbacks to SaaS or remote software specifically. So in general, we have employee mobility. You can use that software from anywhere. Cost savings. You just need a web browser. You don't need a special piece of technology or a a computer with a certain amount of resources generally. Scalability, if you want any number of users can use a piece of SaaS software, as long as there's a server infrastructure in the background to support this. So for example, if it's a lot easier for you to use Gmail, which has like a ton of data centers all over the world, than to operate your own email service on your own servers, right? Because with Gmail, you can just add like thousands of users from your company and not worry about increasing the resources, like the physical resources. But if you're running your own email service or you're using a localized email service, you would have to buy those servers yourself, support them, etc. There's fewer support staff because all of the support is being handled by the third-party company providing the SaaS software, and generally it's pay-as-you-go, like a subscription model. Now, some of the drawbacks are, I don't really know what geographic location here is a drawback, but availability could be a drawback, as well as availability, security, and compliance can all be a drawback. Just because of the fact that when you use software that's managed by another company, you lose control of those. So if, for example, Gmail went down, you don't really have any control over getting it back up, versus if a piece of software goes down on your own servers, then you can do something about it. Same thing with security. That's managed by the parent company. You can't make your system more secure. Like, you basically have to abide by the security configuration that is provided by the company which hosts the SaaS software. Same thing with compliance, data corruption. Like, if the data is corrupted, I mean, there's nothing you can really do about it. And what's another problem is if the provider gets acquired. So for example, like if for some reason, like, I don't know, Elon Musk buys Google or something, he might decide to change the features of the Google suites, right? And there's nothing you can do about that. So this piece of software that you're depending on, that you've been using for so many years, like all of a sudden everything changes because the owner of that software got acquired by another company, and there's absolutely nothing you can do about it. So the next section is going to be about testing. Now, when referring to testing, we're referring to processes or any way that we can test software to make sure that it meets the requirements for that software. Or just to make sure that there are no bugs or that it just works in general, right? So does it do its job? And in general, does it work? So the first type of testing is called static testing. Now, what we're doing here is we're examining documentation, specification, and test plans to make sure that the system that is being planned is the right system. So for example, let's say we want to do static testing on a piece of software that keeps track of patients in a hospital. Static testing would basically be verifying that even before we create the software, all of the plans for that software basically match what we want, right? So we have plans that take into account all the features and all of the requirements, all the tasks we want that software to be able to complete. Now, the term verification is synonymous with static testing because, again, we're verifying that our plans or our documentation matches our desired end product. The next type of testing is dynamic testing. Now, this testing takes place while the software is running and code is executed to make sure that code is executed during this type of testing, right? So what we're doing is we're making sure that the code produces the required result. Now, that might be the required user interface, or that might be the required output in terms of data. But basically, we're using code, we're writing code-based tests to make sure that the data output by the software is what we want. Or more specifically, software meets business requirements. Business requirements just being a term for the tasks that software should be able to accomplish. The term validation is synonymous with dynamic testing because we're basically validating that our software works as we want it to work. Next, we have alpha and beta testing, which are kind of in a different vein. So while previously we were talking about general, just types of testing, here we're focusing more on testing with relation to users. So basically what alpha testing does is alpha testing focuses on actually having members of the company or the team creating the software test the software and make sure that it functions as intended. So the big difference is that in alpha testing, we are focusing, or we're basically having internal team members of the company making the software test the software. However, in beta testing, we're actually giving our software to a small group of intended end users. So we're taking some people who don't work at the company, who will most likely be users of our software, and we're giving the software to them, and we're going to see basically how easily they can use it, whether they find any bugs, and we're going to get feedback from them that we can use to improve or fix the software. So alpha testing, we have members of the internal team or company testing the software. Beta testing, we have a small group of future users or intended users testing the software to make sure everything that works the way it should, and to give feedback as to whether the software meets their needs or not. Yet another piece of software that yet another type of testing is black box and white box testing. So again, we've had sort of some different themes in terms of testing, right? So with static and dynamic testing, we're really focusing on whether the software meets business requirements. With alpha and beta testing, we are focusing on the user reaction to the software. With black box and white box testing, we're kind of focusing on, I would say this is more similar. This is more focused on dynamic testing. So with black box testing, basically what we're doing is we are testing whether the software, whether the software itself does what we want to. So an example of black box testing would be someone let's say someone is black box testing Microsoft Word. They're basically going to use every feature of Microsoft Word and see whether all of those work and whether they meet the requirements for that given feature. So they're just using the software without seeing the code under the hood. Okay. This is also called functional testing, more commonly in the software development world. So basically, you're just using the software and making sure that it works in the way that it should. You are not looking at the code underneath, which is why it's called black box testing. It's just it's not transparent in terms of seeing the underlying code. White box testing is the opposite. So this is going to be done by a software engineer, and usually white box testing is done using code. Now, what this is doing is this is actually testing the code itself underneath the software or inside the software to make sure that it works as intended. So black box testing is just testing whether the software works in a more non-technical manner, right? So it's meant to simulate a user testing the software. So you're just going to go through the user interface or whatever way there is of interacting with the software without writing code. White box testing, you're going in and you are testing the code. You're testing the internal structures and implementation of the software in order to make sure that it works as intended, often using methods like unit testing or integration testing, which again are the more commonly used terms in the software development world. And with black box testing, again, you don't need to know how the code works. With white box testing, you do need to have some knowledge of the code base. Now, another type of testing is called user acceptance testing. This is pretty simple. This is actually similar to beta testing. It's kind of just more broad term for when we have software tested by the intended audience. So we basically give the software to people who we expect will use it, and we ask them whether it meets their expectations. Now, usability testing is another term you might see. This is just testing for how easy to use the software is. Now, anytime we give new software to users, whether that's in the context of beta testing or just in general, we need to give them some documentation to help them understand all the features that are being used. Now, ideally, they should be able to look at the software and understand how it works, but particularly in the case of complex software or just in case there's something that is not intuitive to them, we want to give them information that they can use in order to understand exactly how to use every feature in that piece of software. And there are broadly three types of user documentation we can provide. First is manual, which is hard copy, so just like a booklet, like paper. Then we have online resources, PDFs, websites, or videos. Then we have help files, which are just locally accessible text like we see right here. Now, generally, like on the IB exam, you just have to list these or list some examples. You might have to list like an advantage or disadvantage to, for example, manual user documentation, which would just be like it's paper. So if you lose it, like you don't have any other way to access it. I would say, like, honestly, the questions related to user documentation are pretty straightforward and can be answered with common sense. Now, in some cases, particularly with more complex pieces of software, you might need to actually train users on how to use it. Now, there are three ways. You have in-person classes, online training, and self-instruction. Again, there are some advantages and disadvantages to all of these. With in-person classes, this is like pretty time consuming, right? And it can often be expensive because you need to hire a trainer. You need to have someone take time out of their day at your own workplace to go train a bunch of other employees who are not going to be doing their job during that time. So it's both cost and time intensive. Online training is obviously much less cost and time intensive. It can be done asynchronously, meaning that someone can do it like after work or in between, like during breaks or whenever it is. Additionally, both them and the instructor doesn't need to be taken out of their job or paid just to do training. We might provide some incentives for our employees to do online training, but you don't need to hire an instructor, or you don't need to send employees to another location, taking time out of their day in order to do online training. The drawback is obviously that you don't have a person there to answer questions. You might have some sort of alternative, like being able to email a point of contact or do Zoom meetings, but oftentimes that's not the same as an in-person experience. And then finally, you have self-instruction, which, basically someone just hands you a book or resources and says, go. This is obviously the easiest one. You don't need to create any training courses or spend money creating training courses or administering even an online course. You just hand people resources. On the other hand, this is obviously a lot less easy to access. Users need to be the people you're training need to be well motivated. Also, they need to be able to go out and seek information on their own in a less structured manner. So obviously self-instruction is the cheapest, easiest way for management, but for users or for people who are being trained, for employees, this can be the least useful means of training them on software. Okay, so particularly when we're talking about black box testing before or even dynamic testing, we were going to use methods of automated testing. Now, basically, you're using a piece of software or some code to construct tests that would be run automatically by the computer. At every juncture in your code, as you determine, right? So you're writing tests basically to test whatever pieces of the code you want to test. And this program or software immediately goes to all those points and makes sure that the output of your program matches the expected output. So basically, you're testing all of your code and you're doing it in an automated way. This is a great way to rapidly complete complex or tedious tests that might take a human a lot more time and a lot more pain in order to complete. So this is kind of like a weird, this isn't really that topical, but it's still a term you need to know. This is dry run or tabletop testing. Now, this is basically a type of test where it's like a trace table where you just put data into an algorithm, into code, and see what the output is. And you're actually not even doing this in a computer. You're just doing this on paper, which is why it's often called tabletop testing. This doesn't really match any of the other concepts, but I just put it in here because it was a kind of testing. So I am well aware that it's kind of out of left field. Now, we talked about data loss earlier. We're going to have a couple of slides now talking about how to prevent data loss. Perhaps this should have been put in a different place, but better late than never. Now, there are 5 ways to prevent data loss. We've got failover systems, redundancy, removable media, offsite/online storage, and physical security. Now, failover systems mean that if one system fails, there's another system with the same data and capability that can just take over. I've often seen failover systems in countries where the electrical grid isn't quite stable, or they're prone to natural disasters like earthquakes or hurricanes, etc. Redundancy is a similar concept. Redundancy is more focusing on the resource rather than the data side. But this means that there are multiple servers or hard drives or storage that can just take over or can just be used in case that the primary set goes down. So redundancy is having more than one of the identical resource that can be utilized in case of emergency. And again, similar to a failover system, these will probably have identical data to the primary system. So all of these will have the same data that is constantly updated, but if the primary system that's being used goes down, you just switch to the other systems. Now, another is removable media. We might repetitively update a removable hard drive with data that we want to preserve. And yeah, so it's just removable data just means data that you can connect to a device, connect to a computer or a server, and then you can remove for safekeeping somewhere else. We have offsite or online storage. A great example of this is iCloud, where you can just back up all of your data into an online system that is away from where your computer is located. And finally, physical security is another way to prevent data loss. This basically just means that you put your computer or your servers or your storage devices in an environment that's secure from environmental conditions and from unwanted intruders or anyone, or just basically protecting that system from both people and from natural conditions or natural disasters, or even fires. I guess that's kind of a natural disaster. Now, there are a couple of common causes of data loss. The first one is hardware/system malfunction. If something just goes wrong with the hardware, this could be triggered by some external condition like a power cut, but something goes wrong and you lose data or your data is corrupted. Also, human error. Like maybe you have an intern who accidentally deletes the whole database for your company. That is a human who made an error. Software corruption. For some reason or the other, something goes wrong with the software, and that software unintentionally turns the data into something that can no longer be read, processed, or salvaged. Malicious software, these could be viruses or any sort of piece of software that is meant to destroy or steal data. And natural disasters, power cuts probably being the most common, or damage to hardware, damage to equipment, right? So again, in developing countries, a lot of developing countries, people have backup battery systems to prevent power cuts, but this can often be a challenge in operating hardware. Not so much these days as maybe 20 years ago, because especially I'm envisioning India because that's where my family is originally from. But there, probably 20, 25 years ago, people had computers, but there are a lot of power cuts. Nowadays, in urban areas, it's not as much of a challenge anymore. Okay, so I'm kind of moving on to a very different topic. One thing you need to be aware of is the social and ethical issues surrounding software design. So the first is reliability. So does a program function as intended, right? So if you're delivering a program to someone or you're writing a piece of software for an organization or a person, that program should function as intended. Otherwise, you're doing that person a disservice and probably causing them some trouble. The next issue is jobs. So will a software solution eliminate human jobs? This doesn't mean that you shouldn't write software that would automate tasks, but you need to take it into consideration and think about how you're going to either compensate or deal with the fact that some people are going to lose their jobs as a result of utilizing a new piece of software. Security, is the data in the program secure? It's kind of your responsibility, particularly when you're dealing with customer client data, to make sure that data isn't accessible to hackers, malicious actors of any type. This is kind of very similar to privacy in the sense that as a company or as a software developer, or as someone operating a software system, you have a responsibility to not share user data or use user data in a way that isn't permitted by those users. Now, when we're creating software, this is kind of getting more to the business side. We'll often have stakeholders. So stakeholders are people with an interest in that software or in the business that has created that software or is using that software. Some examples of stakeholders would be owners, users, managers, shareholders, and employees, because they all have some interest or the other in that software and the way that that software functions. So anyone who is connected to a piece of software in any way, that could be financially or in terms of actually using that software, or just simply working on that software, is a stakeholder in that piece of software or in that business. Now, one thing we often want to do is get requirements from stakeholders. So requirements, as we touched on before, are the tasks that a program should be able to achieve. Now, oftentimes if we're getting requirements from stakeholders, it's probably going to be the users, any managers that work in a company, employees that work in a company. These terms aren't necessarily referring to the organization that makes the software, but these could also be like stakeholders. I mean, these stakeholders could also be an organization that's just using the software. So we need to go to them for getting the requirements for that software. Now, some way to get requirements for a software could be giving them that software, maybe giving them that software, or looking at the way that they use other software. And that can be done through direct observation. We can observe how they use a software system, either their existing software system or a new software system that we're giving them in the real world. So we basically just watch them. One of the drawbacks of this is that users may act differently under observation. Although this data can be very useful, I mean, there's nothing better than seeing how users use software in their intended environment. Also, we can do interviews. We can ask users directly for feedback, which can be very insightful, but it can be costly in time and resources because you basically need to like sit down with a person for an individual person with a certain amount of time and get their feedback on the software. Finally, we can use surveys, which are basically just like questionnaires, right? They can be online or they can be in person. And they're great because they're obviously really cheap to implement and very time efficient. We just send them out and have the users just fill them out. But if you don't construct them correctly, you may not get the information you want. It can often be hard to construct questions in a way that don't bias the user, but allow you to get the information you want. And also users may not just take it seriously. Like, when's the last time you've taken a survey seriously? Now, another thing we can use to get information from stakeholders is prototypes. So a prototype is a representation of our end product. Usually it's either a scaled down version of the end product, or it's just not fully finished. In some cases, it may just be a visual representation. But basically what it does is it focuses on displaying the functionality of the product in one or two key aspects. The idea is to give the end users, or give the future end users or stakeholders a more concrete idea of what that product is going to look like and how it's going to function, and then get feedback from them so that the team making the software can more accurately meet the user requirements. Basically, so they can get feedback and then use that to create exactly the piece of software that the end users or stakeholders want. Now, prototyping is a piece of a larger process called iteration. And this is sort of a cyclical process where we're going to get a prototype, we're going to test, meaning we're going to go to the stakeholders and ask them whether the prototype meets the requirements. We're going to analyze the feedback they give us, and then we're going to refine or change the product. And we're going to keep doing that over and over again until the product meets the stakeholders' requirements. This allows for constant and iterative improvement based on user or client feedback. Now, the term iteration actually comes from loops. So if you've done topic 4, you know that a loop just means repeating a process over and over again until we meet some end condition. That's kind of the same thing that iteration is, just in terms of software development. Now, once we've actually created a piece of software that meets the user requirements, we want to deploy that software, or basically send that software out into the real world. Now, the process of launching a new product is called a release. So we have a finished product and we're just going to launch it. That's a release. After we release it, maybe there is a problem that's been found by the users or by your own software development team. And once we find that problem, we can release an update, which is just a file that will fix that problem. Now, I mean, you probably see updates all the time if you have a MacBook. Usually they're for fixing a bug or a security vulnerability to make the system more secure. Additionally, we might also release a patch. Now, a patch is a temporary fix between full releases to account for a bug, some sort of security vulnerability, to upgrade capability, especially if that needs to be done as ASAP, as quickly as possible, or upgrade a driver so that the software remains compatible with the hardware in which it's running. Drivers kind of being the interconnection between hardware and software. Now, this is temporary, so when another release is done, or another release. So we said the release is the process of launching a new product. We could also just release an upgrade, right? So basically, in the next release, the next version of the software, that patch will be integrated, and we may have actually a better or more elegant fix to whatever problem. Like a patch is basically a quick and dirty band-aid in order to fix an existing problem, so that in the next release, we can have a more sustainable and more well thought out solution. Now, another thing to take into account when you're designing software is usability. This is how effectively and efficiently a product can be used. So basically, like if you've ever opened up an app, you don't understand what the hell is going on, and you just it's frozen, and it's just really difficult to use. Like you just click on buttons and it just opens things you didn't intend. It's not very usable. In terms of hardware, some great examples are, with a laptop, if the battery life is too short, it inhibits its usability. The phone, if the screen size is too small, or it's not waterproof, depending on what you do, that could take away from usability. With the digital camera, if the buttons are too small or the software in the digital camera is buggy, that means you're less efficient and effective in using it. Right here is some common factors in usability. But in general, you'll have the kind of questions you'll have are just common sense. Okay, you have a television. What are some possible usability issues with that television? And you just kind of come up with possible problems with the television for any given user. Now, certain segments of the population have usability issues that are different from others. So we could say these are uncommon challenges. For example, someone who's blind, or someone who is deaf, who can't hear at the same level as the general population. They're facing uncommon challenges, fortunately. Now, there's some ways that we can write software in order to improve accessibility, so the entire population, including those with such challenges, can easily access the software, can use the software effectively and efficiently. An example may be a Braille keyboard for the visually impaired, a touch screen, for those who may have trouble using a keyboard for any number of reasons, voice recognition for those who, again, may not be able to use a keyboard easily, and text dictation, which is similar to voice recognition in a lot of ways. So I'm actually not going to go through these IB questions. Again, I don't do this for copyright reasons, but if you look at the link in the description, you can find these slides, and there's 15 slides worth of past IB questions that you can take a look at. I'd recommend using these because, as you know, the IB doesn't really have a textbook. I know there's that textbook written by those two Greek guys, but I think the problem with that is it both tries to address the post-2014 and pre-2014 curriculum. So oftentimes you'll have a lot of information that isn't exactly applicable. So the best way to study for topic 1 is to look at past IB questions, which you can find here. If you enjoyed this video and would like to see more like it, please leave a comment telling me that, and maybe giving me some ideas on what videos you'd like to see in the future. Also remember to like and subscribe this channel so you can see future videos. If you look at the link in the description as well, there's a link to the Discord server where you can ask IB or programming related questions and interact with other people who are maybe going through the same challenges as you are with IB computer science. Have a nice day.